One sample z-test forming in JASP. P-value approach. Researcher Franco claims that the average score of the fundamentals of statistics math 121A is less than 75%. So that is his claim. That is his hypothesis. As we know, a hypothesis is like an opinion, a supposed or proposed answer without any empirical data, and it is subjected to be tested. So to test his claim, he surveyed a sample of 35 of the math 121A students. So we're going to use a significance level of 0.05. And Excel, we did Excel in a previous video. So now we're going to use JASP to help Franco complete the z-test, one sample z-test forming by a p-value approach. So the data is presented in the following table. So data was collected, and these are the values presented. We're going to use these values to perform a one sample z-test forming in JASP, but we need to transfer these values to Excel. These are the scores of math 121A group. So we can simply copy column by column, Control C, Control V, Control C, Control V, and we continue it. So now we have the 35 values copied and pasted in Excel. We need to save Excel, this file as a we need to save this file as a CSV file so that JASP can recognize it. Put it on the desktop and we can retrieve it from there. Hypothesis testing, z-test forming, one sample. So we're going to open the JASP program. Go to Show Main menu, open, go to the computer, browse, or you can just go to the desktop. Browse through the desktop. And here it is, hypothesis testing z-test. Open. And here it is inputted into JASP. So now we go to t-test because Excel has t-test by default, one sample. And we unclick t-test and we look for z-test. So we went to Bayesian paired samples t-test, but z-test is not there. So we go back to t-test. Let's go to one sample, see if it is there. Here it is, z-test. So you go to t-test and you go to one sample, classical one sample t-test, click on it, and here you have z-test appearing, one sample z-test. You transfer the variable, all right? So let's repeat that. Go to t-test, one sample, and here you have z-test. So you, by default, JASP is taking student, t-student, so you click on Z, and you transfer the variable score to variables, and The value is a 1 till because we said less than the test value. We go to the wording, less than 75%. That's what he said. So we click on less than, and the test value is 75. That's what he said, less than 75%. And here is the output that JASP is providing. And the p-value is actually 1. Now we can recall from the decision criteria reject the null if the p-value is less than the significance level. Remember, the significance level we have is 0.05. And do not reject the null if the p-value is greater than the significance level. Now we need to state our pair of hypotheses. To do so, we use this table because we've got to do it in convert the worded hypothesis to symbolic form. And the keyword there is less than, which is an alternative symbol. And here it is pointing towards the left, HA, and HO is, you can put HO as the equal sign or greater than or equal to, but the important thing there is that less than 75. So let's do the translation to symbolic form. It sub O population mean, because it's referring to the population mean. So we have to use the symbol mu. It's equal to 75. Bear in mind, null statement always has the equal sign. What he said now, which is an alternative statement, you can use 1 or you can use if alternative. He said that the mean population mean is less than 75. That's what he said. So here's the pair of hypotheses. Always begin any hypothesis test with the pair. For the z-test form, you must convert it to symbolic form. And here is the output for JASP. We can just click here and click copy and paste. Let's paste it in a text box so we can maneuver it at will. So we can clearly see the p-value is greater than the significance level. So let us state that. So here we have stated it, the p-value of 1.000 is greater than the significance level of 0.05. So according to the decision criteria, we are not to reject the null hypothesis. Do not reject the null if the p-value is greater than the significance level. So let us state that. So here we have stated that the null hypothesis is not rejected. Now, if the null hypothesis is not rejected, then itself is the conclusion. If we had rejected the null hypothesis, then the alternative statement would have been the conclusion. But since we keep the null hypothesis, then itself is the conclusion. So we have to state that. And what the null hypothesis is saying, that the mean is, well, equal or greater than or equal to. Greater than or equal to. It's not less than, is greater than or equal to. So that's where the usefulness of the arrow in the alternative with the equal sign is important. So the mean is actually not less than 75. It is either equal to or greater than 75%. So this is the importance of having the equally, the arrowhead also in the null statement, apart from just putting equal, because clearly it might not be equal to, it might be greater than or equal to. Because if we have to look for the description, if we have to look for the mean, the sample mean, let's look for it in JASP. So we can go to descriptives, variables, score, we go to statistics, and we can actually calculate the mean. Let's look for the mean. The mean, the sample mean is actually 84. Okay, the sample mean is 84. So clearly 84 is not less than 75. It is greater than 75. So this is importance of the inequality sign in the alternative statement with the equal sign. So again, the null hypothesis is not rejected because the p-value is greater than the significance level. So we keep the null hypothesis, and instead of having it just the mere equal, have it with the greater than or equal to. So that will be our conclusion. The mean is greater than or equal to 75%. Actually, it is pretty much greater than 75% because here it is at 84%. So hence, the mean is greater than or equal to 75%. So here is a one sample z-test for mean in JASP using the p-value approach.